restriction 1/3 close to the rear plate, to the front plate, excuse me. CPAC, in checking with my index, I find that the content page shows the ECOS crash recovery 02 Golf-2 is not flown. You have that only on the ground, over.
Roger, Owen. Essentially all it is all power systems to inhibit, battery off, chargers 1 and 2 off, chargers inhibit, and DEPIU off.
All of the switches are off except bat cells remain connected and the panel bus feed stays closed. Is there anything else that your last switch was unreadable, over?
That was a DEPIU off, and yes, that's fine.
And Space Lab to Byron.
Go ahead.
Isidoro would like you to shake, rattle, and roll that drop by putting on 0.1 hertz frequency vibration at maximum amplitude. Over.
Okay, we'll go for 0.1 hertz at maximum amplitude. Stand by. And now I have it about a 90-degree contact angle at the feeding end plate, which is a smaller one, and it's maybe a 75, 80-degree contact angle, so there's a slight concavity in there.
That's an interesting shake.
Okay.
And Space Lab, be advised, we're doing some commanding on 19, and if we get those alert messages, we'll disable them again.
Okay, be advised, Bill, you got a UHV stop and a flashing ops light.
Copy, UHV stop, light flashing.
Okay, Owen, that is correct. That's what we expect. Over.
And Space Lab for Byron.
Roger, go ahead, Mike.
Okay, Isidoro's interest would be in the possibility of forming standing and traveling waves on that zone. You're beginning at 0.1 hertz, and he would like you to ramp that up, observing as you go, and maybe giving us any observations you can see. Over.
Okay, stand by. I now have 0.1 hertz in there, and maximum amplitude, and I don't see anything, so I'll start ramping it. Okay, we're starting to get something at 0.2 hertz now. CPAC, I just missed getting your parameter 71 set from 1 to 0 by a few seconds. It needed 5 minutes prep, and I missed it by just a couple of seconds there, so your parameter 71 is still set at unity. Over. Outside that, we should be counting down to the proper T0 time. Over.
Copy, Owen.
Okay, and Space Lab for the for the MSCR people, we've got a nice standing wave here at 0.4 hertz, 0.4 hertz. Beautiful.
You're seeing something nobody's ever seen before.
I'm sorry?
You're making the observation that nobody has ever made before. Congratulations.
Okay, boy, it's really spectacular, too, let me tell you.
Okay, we're very happy with that. Now, the final stage of destruction of that drop, would you please stop vibration and now ramp the rotation rate? Correction.
Okay.
After stopping vibration...
Say again, Mike? The vibration is slowing down now.
Okay, after the decay of the vibration is complete, would you then begin rotation of one plate at 10 RPM? The choice of plate would be the rear plate closest to the largest end of the drop.
Okay, the rear plate, and I've been doing ISO rotation here at 5 RPM.
Negative, not ISO rotation, single rotation, rear plate, 10 RPM. We want to watch the spin up.
Okay, work off. And Marshall Ops Space Lab for the MSCR people, we're just going to be standing by here for a few minutes until everything settles down, okay?
Right, Byron, and I believe Ulf has some traffic for you.
Well, Space Lab, this is Marshall Ops, this is Ulf speaking. Byron, can you give a resume UHF enter? Over.
UHV enter, Wilbo.
Sure, I'm sorry.
Steady op flight.
Yeah, UHV.
No problem. Steady op flight.
Okay, good. And can you put a little note next to the UHV? A little decal or so, over.
Stand by. Yeah, a little bit, Vubo, what you want to say.
Well, the ops lamp can flash again, and when it flashes again, you want to give it an open and close and resume, and that's going to happen several times. Therefore, I thought of putting a little note next to it.
You better copy stuff down later, or
Okay, if
off
you're
for a little bit.
good. If you're ready to copy, then I give you it. 3 steps.
Okay, Marshall, here we go with the ISO rotation. I'm sorry, single rotation of the rear plate at 10 RPM.
Copy.
Ready, mark. Stand by. Okay, I forgot to set the front plate speed to 0, so just wait a minute here for everything to settle down again.
Okay, Byron.
Let ops are on again.
And take care, if you can, not to rupture the zone.
Okay, here we go. Rear plate rotation, ready, mark. Beam firing that time, feedback.
Repeat.
Space Lab, this is CPAC.
This is really spectacular.
I wish I could say it with you.
I might get rid of my air bubbles here too. They're heading towards the outside, believe it or not.
Space Lab,
One's in the center and one's in the outside. Go ahead, Mike.
Space Lab, this is CPAC. We have just not got data back. If between the FO prep complete and T equals 0, we would like you to put the PCF in if you have time.
I couldn't hear you last. Between FO prep and something else, you'll have to say again.
Set PCF 71 equal to 1. If you can make it between FO prep. When we just confirmed T equals 0, ignore that.
Sorry, is this Jim Birch? I can't really read you very well.
This is Randy Bounds. Bill Roberts has gone SOPG.
Hey, I'm sorry. I still, if you have some instructions for me, you'll have to say them again more slowly, please.
Just disregard, Owen. We'll.
Okay, Marshall, standing by here with the FPM.
Do you have steady 10 RPM on the rear plate, Byron?
Steady 10 RPM, and that's steady flow pattern now.
Okay, now if you can put the same ramp on the front plate, also up to 10 RPM, then we will have ISO rotation.
Mark one frame. And we're ready for front plate rotation. Mark.
Owen, this is CPAC.
Ben?
We are showing MPD arc jet firing.
What? Thank you. Okay, we've got a C mode, AM4, C mode isolation, rotation now, MSCR.
In that case, you should be very careful not to break it, but I suggest at this stage you stop rotation on both plates and we can watch the decay of the C mode.
Okay. Well, it's now coming back to an M4 shape, but it's really just a little bit off center here.
Okay, and there's other traffic waiting to come up, so we must get off the loop. We'll leave you just at this point for a moment. Over.
Remember to stop both rotations. Ready, mark.
And And Space Lab for Owen, we have the 01 PI would like to talk to you about the science that he would like to have you take with the Nikon camera we discussed earlier.
Hey, let's wait about 15 seconds here until the CPAC experiment is finished, and I'll be ready.
That will be fine.
And a marker for the tape recorder. The decay of the C mode, the plates have stopped, and it's been, I don't know, 20, 30 seconds, and there's still quite a bit of rotation in the fluid. It's really terrific.
That's magnificent.
Go ahead, 01 PI.
Owen, ISO is looking at the limb at the present time, or very shortly, and what we would like you to do is to use the Nikon camera to record the location of the limb and the detail of the background surface albedo.
Okay, so you'd like a photograph of the limb directly at the port axis, is that correct?
That is correct.
Okay, and how often do you want photographs?
Oh, and just to point out, to remind you, the ISO is looking out along the minus Z axis, and that is the direction in which you should take the picture.
Okay, fine. Minus Z axis, excuse me.
With regard to the frequency of taking pictures, a few pictures throughout the duration of about the 1 hour would be fine.
I understand. That can be done, and we'll take several exposures to make sure we get something that'll show up in the frame.
Thank you very much.
I think the ASA 400 cell would be the best here.
Okay.
Hey, Marshal Ops, Space Lab for the 327 331 PI.
327, go.
Okay, Mike, the fluid's spun down now, and I'm standing by.
Well, Byron, it's been the most thrilling day working with you. It's been tremendous, and we've worked, you and the FPM, very hard. Congratulations, it's been terrific. I think that the only thing that remains now is to clean up, and if before handover you have a chance to set up John Paday's in the dry and hand it over so that when Ulf gets a chance tomorrow, he can do a John Paday and then one or two other things as well, then I think it's time to go to bed, and thank you very much indeed.
Okay, well, I can't wait to see this the video and the film. It's really spectacular to see this column out here.
Okay, Byron, I've got a couple of messages to pass on to Ulf, if you wouldn't mind at handover. Can you do that?
Sure, stand by one. A question for CPAC, do you have any other runs coming up?
Owen, that's affirmative. We have one scheduled at day 8, 1350. And also one at day 8, 1620, and day 8, 1840.
1850, 1620, and 1840, thank you. Okay, and Mike Haynes, go ahead with your notes for all.
Okay, Byron, the first one's for you. If you get a chance to install John Paday's end plates, could you please video record their state before placing them in the FPM? And he wants an end-on and side-on, that is profile view of each plate. I think he wants to assess the condition of the anti-spread barrier. Over?
Mike, we lost you. You cut out halfway through.
Okay, I repeat. John would like you, if you're setting up the experiment for Ulf to do in the next shift, to make a video recording of the state of both of his end plates before you install them in the FPM. And he wants an end-on and side-on, that is profile view of each one. If you can do that, please. Over.
Marshal, you'll notice those route skip 21s just after CPAC was finished, fortunately.
Yeah, that's great. I'm glad we got the data. We copied the route skip 21. And Space Lab for Byron, Chuck Ullman would like to talk to you, but first I'd like to pass on a message from the PCTC at Marshall Space Flight Center. Everybody says hi and wishes your best, and they say they hope to see you in a week or two.
Sounds good to me, Bill. Can't wait to get back. In one sense, another sense, really don't ever want to leave it up here.
Okay, and Chuck Coleman's ready to talk with you.
Space Lab Byron, this is 102 Larry Young. Good evening, Larry. How you doing today? Just fine. We got something a little different for you this evening, Byron. We want to look into the question of spatial orientation and the relationship to the workplace. Byron, I'm going to outline the problem for you, which will take a few minutes, and you can work on it at your leisure during the AOS. The basic question is, as you know, you've been in zero-G, but you have been working in an upright mode. That is, you've been working all week with your feet basically down toward the Space Lab floor and working up against the walls as though they were relay racks in the laboratory, which is the way most of the space workstations are designed. And we want you to look into the disorientation and performance effects of working inverted or supine. If you understand the purpose of that, we'll go along with this little operation experiment. Copy? Go ahead. All right. In particular, I want you to look at working upside down, and the task that I want you to do is to measure the electromagnetic interference in the Space Lab by using the Leslie CRT, which you're familiar with, that is in our storage. I want you to take out this Leslie CRT and using it in the open position, that is with the BNCs having nothing connected to them, I want you to measure the magnitude and the dominant period of the electromagnetic interference at a given place in the laboratory. And I want you to do this repeatedly, first in an upright position with your feet toward the floor, then in a 45-degree, a horizontal, an inverted position, and finally in a position in which you are supine, working up against the ceiling. Do you understand? That's affirmative, Larry, I do. Okay, all right. And now the things I'd like you to consider when you do this is, first of all, we will be recording it, and you will use TV09 with camera 2. And so try to remain within the field of view of camera 2. We will also want you to consider the effect of tactile cues and loading. And toward the end of this exercise, you might see if by generating tactile cues of your feet against the ceiling, you change your sense of down. You might, for example, work inverted with your feet toward the ceiling and having Owen upright in your field of view, and then see if you can, by generating tactile cues against the ceiling, you can flip-flop your sense of which way is up from the visual to the tactile down. Do you understand? Space Lab 1, Byron, this is 102. Do you copy? Space Lab Byron, this is 102. Do you copy? Space Lab Byron, this is 102 in the blind, and I will continue with the discussion of the working upside down operation. We're interested in whether the visual dominance of the ceiling and the walls has become more important to you after a week of working in zero gravity. So the specific activities are concerned with the performance and your sensation of comfort while working with your feet directed toward the floor of the spacecraft, toward the ceiling, horizontal and 45 degrees. I would also like you to comment on your ease of moving up and down the length of the spacecraft. Most of the time, it's done in a face-down attitude, like a fish going down the aisle of the Space Lab. Is it disorienting to move down the length of the laboratory in a face-upward or sideways position? Space Lab, this is 102. Do you copy?
Space Lab 102, Byron, we're told that you are copying the uplink. For your information, the readings that I've just recently taken using the Leslie oscilloscope here in the science monitoring area at Houston give me, of course, a dominant frequency of 60 hertz or 16 milliseconds, and the amplitude that I pick up is about 1.5 millivolts. When I touch the case, the bottom of the case with my hand, it jumps up to 7.5 millivolts. Let us know what you find in each location. But of course, Byron, the real importance of doing this is your assessment of the comfort of working in each different location. And we will document the performance using the Space Lab TV. Use TV-09, camera 2, and an onboard tape recorder.
And Space Lab for Byron, this is Mike Haynes. And Space Lab for Byron, Mike Haynes in the blind. One further point for Ulf, if you have a chance at handover, is to tell him that John Padday would like to omit point Sierra 3. Omit point Sierra 3 from his run. And you might also remind him that at 17 plus 59, somebody may have a chance to take a photograph of my hometown as you pass over it. Once again, thank you for a splendid shift, and we hope that Ulf has just as good a time tomorrow. Good night.
Okay. Roger, Mike. Copy you loud and clear, and I understand we want to do run 329 Charlie for John Padday. Is that affirmed?
Affirmative. Omitting point Sierra 3.
Okay, omit point Sierra 3 and run 329 Charlie. Copy.
And Space Lab, Marshal Ops for Byron, over.
Go ahead, Wilbur.
Yes, Byron, we have up to you a message number 136. It is a draft, correction, 139. It is a draft of a little crew experiment. Several crew people have already made some inputs, Ulf and Bob and Michael and I, and we would like to iterate that a little bit around and see whether there are some ideas of things we still could do from our side. Over.
Okay, Roger, understand. What's the message number again, Wilbur?
It is 139, and I think I just hear it has not been uplinked yet. We'll stand by one.
Okay, Roger, we'll be looking for it.
And Space Lab Byron, this is 102. Do you have any questions about that long monologue I gave you on spatial orientation?
I don't think so, Larry. It's all very clear and understandable, and I'll get on to it shortly here.
Okay, and don't forget about 6A this evening.
Okay, and I don't know how much more AOS time we have. Wolf is just coming on the headset now. Yeah, this is Wolf. I got the message somebody wants to talk to me.
Space Lab for Ulf, this is Mike Haynes. Good morning.
Good morning, Mike.
Well, I hope that you're going to have a nice shift. We've just had a marvelous time with Byron with the fluid physics module, and a number of us are extremely satisfied. I hope you're going to have time now to do some more interesting observations that we have lined up for you.
Okay, Mike. Will you be in the PUCC still in half an hour time from now?
Affirmative, yes.
Okay, but maybe you can quickly summarize what you have in mind to do.
Okay, the first thing is that with the FPM in its present setup, we've completed some runs, and we want to do now John Padday's 329C, omitting point Sierra 3. And I'm not sure whether Byron has time now to begin the setting up for that, or whether you'd like to leave it for you. Over?
Yeah, Byron gives it over to me, hands it over to me, but he's busy for the time being.
Okay, well then, John Padday would be very interested if before you install his special end plates, you could make a video record of their state. He's particularly interested in the edges, but he would like end-on and side-on or profile views of the end plates before you install them, and your observations of the anti-spread barrier.
Okay, and he's talking about the end plates which are installed now. It's not absolutely clear to me what he's asking for.
Okay, if Byron has already got the end plates in, that is the 329C end plates, then I assume that he's made those observations, because I passed him that message a little while ago. Over.
What I see here looks more like Isidoro, not like... Yeah, he says he has John's back end plate in.
Okay, that's correct, yeah. Then before you install John Paddy's front end plate, perhaps you just take a video picture of it end on and side on.
Okay, I'll try that.
Space Lab 102 for Byron. This is 102.
But you go ahead, 102.
Byron, is probably obvious, but when you do this work in different positions, the oscilloscope should be upright relative to your head. In other words, so when you're working upside down, as it were, the oscilloscope should also be upside down. So you're always looking at the oscilloscope. Okay, and Bill Bach shares our interest in this and its application to future training.
And we'll see you at 12 plus 32 at Hawaii, you guys. Great shift.
Yeah, it was a great pass. Thank you, guys.
This is Marshall Space Lab Operations. We're just about a minute away from reacquisition of communications with the Space Lab as we approach the ground station at Hawaii.
Space Lab, Marshall Ops through Hawaii for 5 minutes.
Mr. Chuck. Morgan, Jean-Louis.
Good morning. How was your day?
Long, but very productive. Outstanding, as a matter of fact.
That's what we heard down here, too. Looking forward for another one.
You betcha. You guys are just early. Your compatriots up here don't come out till 1 o'clock.
Yeah, we just thought we'd get a jump on the system here. We're looking at the sunset. It sure is spectacular. Or is it sunrise?
Down there, up here.
We're looking at your view of it.
Oh, yeah, they are.
And Space Lab, Marshall Ops, Byron, if you're still there.
Roger, go ahead, Willow.
Yeah, I just still did not give you this little three-step procedure which has to be done if the UHV ops lamp would flash again. Over.
True, roger that. That was one of the things we're missing. And it's flashing now.
It is flashing? Okay, when it is flashing, you do an open 102444 and a close 4010, and then resume UHV enter. Over.
Okay, that's complete, Willow. Got a steady off flight.
Okay, and be informed, Byron, that this could happen again several times. So if somebody wants to know what to do with it, just do about the same 3 steps. Be reminded, though, that it's not intended to be done continuously. So if you have to do this about 3 or 4 times, then just give it up and give a halt. UHV 31 enter. Over.
Okay, go ahead and read me those again, please.
Byron, the 3 steps, the open, close, and resume, can be done when the ops lamp would flash again. However, do not repeat this procedure more than about 3 times. If necessary, a 4th time, just give it up and give a halt UHV 31, enter, over.
Okay, copy that. Go out to Space Lab.
Go ahead.
Are you familiar with the fact that we ran about 3 or 4 CPACs, and just after the last one, about 1 minute after FO complete, we got row skip 21 message again?
We copy row skip after the last FO, over.
That's right. I was wondering if you were already familiar with that situation, because my question is, I wonder if we ought to give it a row op now, or wait until we are closer to the next CPAC run before trying a row op, over.
We get you an answer, over.
Again, Zubo.
We like to wait with the row up, over.
Hey, delay the row op until near the beginning of the next FO, all right?
That's affirmative, over.
Going LOS on, we'll see you at 12 plus 4, 8.
Okay, the 102 stuff will be on VTR number 1, last 16 minutes.
Roger, VTR 1.
This is Mission Control Houston. We're LOS through Hawaii. A very quiet pass from the orbiter that time. We'll reacquire through the teeter system in about 10 minutes. When that occurs, the Mission Control Center will come up on Air to Ground 1 on Mission Audio, and we'll do a summary tag up for the handover with the flight crew. That will be a reasonably brief Air to Ground 1 contact, and when that concludes, the next opportunity for UHF acquisition with the flight deck will be in 2 hours and 10 minutes, about an orbit and a half from now, through the ground station at Ascension. That's, of course, an extraordinarily long LOS period, but as is always the case, the Mission Operations Control Room here has the option and the authority to contact the flight deck on Air to Ground 1 at its discretion, and of course the flight crew can do the same during any teeter's pass. Mission elapsed time is 8 days, 12 hours, 38 minutes. We'll be AOS in about 10 minutes. This is Mission Control Houston.
This is Marshall Space Lab Operations. We're about half a minute away before we reacquire communications with the Space Lab through the Tracking and Data Relay satellite on S-band. And in this upcoming AOS pass, we anticipate the crew completing its handover from the blue shift to the red shift, and for the red shift to be starting its daily planning as we go into this 10th day, this extra day of flight for the Space Lab.
Yeah, it wasn't too much in the field of view when I was up tied up on the top of the ceiling. Again. This is a very nice viewpoint. It's a little harder to let go of things, but certainly no problem working here.
You're the 19th guy, right?
And here I'm fine on the ceiling. There's absolutely no EMI whatsoever. And there's no problem working up here. Let me turn around.
Space Lab Marshall Ops, AOS for 51 minutes through Tidris.
Shotgun, we got you loud and clear.
Okay, at this point, the MOCR would like to take over and do a handover for their side, and when they're finished, then they'll turn it back to us. And at the Red Team's call, we'd like to spend some time during the next 20 minutes or so discussing the PCAP.
Okay, Wolf is here, Bob. It's been in and out, so I want you to hold off a couple minutes.
Yeah, we sure will. And Space Lab, the MCC tells us they're standing by for your call.
Houston, this is Space Lab, over.
Go ahead.
Roger, I'm sorry. I thought you were expecting a call from us.
Yeah, we are. We were waiting for your go to see if you're ready for the handover briefing.
Okay, stand by.
Okay, we're standing by for both flight deck and payload folks.
Just a moment, I have to get Bob here. Flight deck's already handed over.
Okay, I can go ahead and you can just relay the information to him if you prefer.
Better.
Say again?
Yes, then we're ready. Go ahead.
Okay, first for the red shift, flight day 10, just want to say that there's no changes to the message that was sent up. That's message 130. And for John, the Edwards weather and runways are all looking good. We do have some notes for blue flight day 10, which I mentioned to Brewster over Hawaii. One is that the E-23 attitude at 9 days, 7 hours, and 10 minutes has been deleted, and the IMU align moved up to that time, and the minus Z sun attitude extended for about 1 hour. A new attitude timeline will be uplinked with those changes. Also, we will be doing an ECOS crash, which will be commanded from the ground at approximately 9 days and 11 hours. And the only thing the crew will have to do will be to re-IPL ECOS just prior to the circ pump test at about 10 days and 11 hours. The reason we're doing this is because of the ECOS crash that occurred in flight and because of some anomalies noted. An in-flight dump would require about 30 minutes of continuous high data rate. This procedure causes ECOS to crash and dump to the Space Lab mass memory unit, where it can be recovered post-flight. These will also be incorporated into your CAP update. Also, for Brewster, I would like to know if there were any questions on the circ pump test.
No.
We copy. And also a question for Owen or Bob. This is a question regarding the SAL for RMU. He'd like to know, are the launch lock pins installed, and is the cable harness bracket installed?
This is Owen answering. I asked Bob that question. He's not on the line right now, and he's the one who did them, and the answer was yes.
For the cable harness bracket, we'd like to know when you did them. Was it before or after the hot test?
That must have been before the hot test.
We copy before the hot test. And that's all that MOCR has for the handover.
Yes, one question. When is that ECOS crash going to happen?
It will be after all the experiment operations are complete at approximately 9 days and 11 hours. We will get a go from Marshal Ops for that.
Thank you. Houston, Space Lab.
Go ahead, Space Lab.
Okay, review on the status of the SAL. That cable bracket and cable are both on it and in their so-called launch or re-entry also, I guess, position. They were put there when we came back in from the 22 operation, when I mistakenly deactivated it, 2-3 days ago.
Stand by, Bob. Space Lab, Houston, RMU is saying that it had to be, the lock pins had to be removed and it had to be extended for the hot test. And we want to be sure that they were put back after that test was complete.
Okay, yeah, the launch locks have not... Stand by. Bye. The inner hatch has not been... remember what happened was I deactivated it too early, and then they had to put it out for hot test. So Owen had to reopen the inner hatch and take the launch locks back out. And then he took it out, put it out for hot test, brought it in at the end of hot test, but the inner hatch has not been opened since then, and so the launch locks are not in place at the moment. And when I asked somebody about deactivating the SAL yesterday, either you or Franklin, I think, Anna, They said that was going to be part of Space Lab deactivation tomorrow.
We copy that,
But
Bob.
at the moment, the little screw launch locks are not in place. Of course, that's not really a requirement for entry because there's no mass on the table anyway.
We copy that, Bob. Bob, could you also give us your scenario on the cable harness bracket?
Yeah, on the day that we brought the SAL in for 22 and took 22 off the SAL, we put the cable harness bracket back on and put the cable on that bracket as we would for deactivation. And that's where it is currently. Has not been changed. That has not been changed since then.
Could you confirm that the bracket was installed for the hot test?
Confirm. Bracket was installed for the hot test.
We copy. Space Lab Houston.
Roger, go ahead.
Yeah, Bob, in talking this over with RMU, he'd like you to put the launch lock pins back in during deact, and we'll give you another call on that.
Okay, I understand that that'll be made part of the deactivation procedure, and we'll take care of that.
That's firm, and we're through with our handover, and I'm going to hand back to the marshal ops.
Okay, thank you. Again, putting the launch locks in if they don't need to be in for entry.
We understand that, John.
300.
PSCC, you calling Space Lab?
Columbia, Houston, a message for John.
Say again, over.
Yeah, John, just an answer to your question on the launch lock pins. We realize that they're not required for entry, but it's not mandatory, but they are highly desirable, and they'd prefer that you put them in if at all possible.
Certainly possible to do it, but it's an unnecessary risk opening that hatch again when you don't need to. I understand that you can re-enter with 15 to 20 kilograms on that table. There's nothing on that table. We plan to enter with a metric camera on there, and that's my concern.
We copy that, John, and we'll talk it over with RMU.
Space Lab, Marshal Ops.
Marshal Ops, go ahead. This is Space Lab.
Good morning, all. If you fellas have finished with your handover up there, we're ready to talk about the PCAP on your call, and you might pass along to Owen that AD4Y copied his message on the scratch pad line.
Okay. Bob and Owen are still talking about CPAC operations, so that's still part of the handover. But if you have something for us, you could go ahead as well, Chuck. I'll copy that.
Okay, that's fine. Also, if you'll look at hour 13, which is the current hour, the uplink copy that you have shows 300 ops for you beginning at a little after 1400 hours.
That's correct.
Yeah, we're moving that 300 ops activity to about 1800 hours, and we're going to let you start.
Okay, Okay, that will be from 1800 till 1900, something like that.
Yeah, there's really no need to make a note in the PCAP on that one. We're just moving it downstream, and we'll talk about the details of it when we talk to you a little bit later. What we're doing is opening up some time for you to begin a 201 setup at about 13 hours and 30 minutes.
That sounds good to me.
Now, what we'd like you to do is linear threshold with you as the subject, and then at about 1430, that's just a suggestion, switch over to Bob as subject and do caloric.
That's exactly what we had in mind. Thank you.
Okay, and the only deviation we see from that OLF is at 13 plus 3.4 when we have KU coverage, 13 plus 3.2, I'm corrected. We have an operation which WIBO will read up to you on RQ on the MSDR, but that should only take a few minutes, and then we want to leave you clear to do the 201 stuff.
Sounds great. Thanks a lot.
Okay, now on Bob's side, if you can write it onto his side, he can join you with the 201 setup after the CPAC FO13, and he should be through with that at 13 plus 5.0.
Wait a minute, he starts 13:40. Okay, 13:50, 10 minutes, okay. Mark my FO13, I presume you mean model number 09er. Verify that with CPAC, please.
Stand by. No, it's model number 17, Owen.
Copy that.
It's model number 17 and another model number 17, and we'd like TCF 69er equals 0.
We'll need then a exception monitor subtimeline.
And stand by, Owen, we'll get you a T0.
Okay, as long as you work on CPAC or somebody, maybe we go to the update here of the pickup.
That exchange between Chuck Lewis and Ulf Mirbold as they update the PCAP, the Payload Crew Activity Plan, the detailed timeline, which...
Okay, in Space Lab for Marshall Ops, on that CPAC run, the T0 time is 341 and then 0350. So it's a correction. It's not 5 hours, but it's 03 hours. Over.
Okay, T0. Say again, Mobile.
Oh, the T0 of the next upcoming CPAC run reads day 341, 03 hours and 50 minutes.
Okay, copy that. 341, 3 hours, 50 minutes.
And also the CPAC PI asks whether Owen or Bob, whoever is available, could sometimes do a hold restart. Each 15 minutes would be perfect, but of course we cannot always do that, especially now that we work on 201. Over.
Okay, let's concentrate on 201, otherwise we screw up that one.
We concur.
Okay, what exception monitors support that timeline for 17 here? G06?
Stand by, we get it. Yes, Bob, that's Echo 06, over.
Okay, Echo 06. Now this is only going to run for 600 seconds, right? Okay, 900 seconds, got it.
Yeah, and we'd like you to do a hold restart.
In order to get a second 15 minutes, is that what you're talking about?
That's affirmative.
Okay, we'll try to fit that in around 201.
And the T0 time, GMT 341, 5 hours, 50 minutes. Negative, standby. 0350 minutes. Got the hour wrong. 03 GMT.
You got that? Okay, we got that. Okay, Chuck, can we press on for the daily planning?
And Space Lab, Marshall Ops, I'm sorry with all the corrections and the misunderstanding. The PI finally realized that it should be really 05. The RGMT 05, over.
Understand, GMT is 05 and 50 minutes.
That's affirmative.
Okay, Wubo, can you brief me on the daily planning?
Ulf, why don't we let Chuck continue with mentioning all the changes to the PCAP for the first few hours, and we get back. I mean, the first thing is really what we already heard, and that is that you guys are going to do this very interesting stuff on 201. Over.
Yeah, I think that's a good idea to go through the linear threshold for me and the calorics for Bob.
And also be advised, Ulf, there's this message 139, which came from Mike and me, and I'd like you guys to review that and come with us some suggestions. Over.
Okay, that is message 129er, is that correct?
Negative, 139er. And it had been uplinked about half an hour ago.
Okay, we'll take a look for that, Wubo, and come back to you. Let me raise one question related to the tape recorders. Byron briefed me and said tape recorder 1 is at the end of the tape. Is the ground going to rewind or dump it? If not so, is the tape change at 15 hours and 30 minutes and the other one at 17 hours and 10 minutes still on?
Stand by. That's affirmative, Ulf, and you got that absolutely correct. And we'd like you to also change out AV1 anytime. Right now is fine.
Okay, as soon as we are done with the daily planning, I'll do that. And I'm very happy and satisfied to find that 33 run on my side of the PCAP. I think that is the famous REF 141, and I hope that we get also a minus C-nadir attitude for the ship.
Copy that.
Chuck, a question for you to relay, please.
Go ahead.
It's not a question, but information to the ISO PI, who has me taking some pictures of the horizon for him. Those will be on film roll 122. So when he goes to look for his horizon photographs, we should find them on that roll post-flight.
Roger, copy 122.
Hey, John, I buy you a bottle of champagne. That's great. Is Klaus Wilhelm still in the smoker? Fox?
He was a short while ago, and I can try and relay a message to him, or if you'd like to talk to him, if we get a minute, we can bring him up too.
The question that he left me with was, he suggested that we take command of the 19A instrument from time to time at high magnetic latitudes and switch from high to low sensitivity, but remember to leave it in the original condition with a full energy sweep. Now, it turns out if we roll in the ECAS task and do those things and then take out the ECAS task, when we do so, it will remove his experiment from operation. And so I don't see any way to perform that optimizing and leave it still running. And so that was my comment for him, if you can reach him.
Okay, we copy that, and we'll get back with you.
Let me make a comment on that. I think we have at least 16, which runs also without ECAS when you remove it. I'm not sure whether 19 does the same. You have to check with the ECAS guys.
Copy.
Chuck, I guess we'll have to know not for the linear threshold, but for the calorics, we'll have to know something about when to start in order to have either downlink. Because we don't have any flight plans now to show us video downlink, or real-time downlink capability, KU band.
Okay, best I can tell you right now is that we get KU at 14 plus 30, and we'll work on the patching there.
Okay, no, that's fine. As long as we know that's the time, then we'll just figure to start the calorics at 14 plus 30.
Copy.
Easy to get along with. We're easy to get along with, you know that.
Roger that.
choke. Hey, Chuck, is there any chance that I could talk to the 33 people?
Stand by. Looks like. And Spacelab Marshall for Ulf, confirmation on the 33 run that's still there, and we may have some more information for you, but it's in good shape right there.
Okay, and someone will tell me eventually something about the N3 contamination run, right?
About 12 and a half minutes remaining in this AOS period, and replanning for this redshift continues. And the replanners are next to the room, which has the crew interface coordinator, Chuck Lewis, and the payload operations director, Tom Riccio of the redshift. Right next door to that pod area is the replanning room, where these people are busily putting together the updated plans for this redshift, which remains as we go into this extra day, this 10th day of Spacelab flight. Some of those updates have already been voiced up to the crew by Chuck Lewis. The crew has been asked to set up for Experiment 201, which is one of the vestibular series of experiments. Dr. Rudolf von Baumgarten is principal investigator of that, and there's been quite a bit of Experiment 201 activity that's been done during this mission. But additional data is always valuable in an experiment such as this, and therefore they have asked Wolf Mirabel to perform the linear threshold portion of that experiment, beginning at the 13-hour, 30-minute point and carrying that through until about the top of the hour. And then, following the linear threshold, Bob Parker has been asked to be the subject for the caloric stimulation portion of 201. He will join Ulf Mirbold in that after he has completed his work with running the functional objective 13 for CPAC. That is essentially a passive experiment. Bob Parker will be doing that as Ulf Mirbold performs the linear threshold.
Spacelab Marshall for Ulf.
Stand by a second, I'm changing tape.
Ulf Mirbold is setting up one of the videotape recorders so that the 201 experiment can be recorded.
Spacelab, you guys look at the route 21.
Yeah, we see it. Yeah, we'll take care of it from here, Bob.
Okay, Chuck, go ahead.
Okay, Ulf, just confirm, please, that AV2 is completely changed out.
AV2 has 24.6 minutes tape remaining, and I'm working on AV1. Change it out.
Okay, we need you to change out AV2 also, Ulf, but in the meantime, please, before you do that, as soon as we get good data lock, we're going to ask you to do a MSDR procedure.
Okay, let me quickly finish that one here and then come back to you.
Okay. Spacelab Marshall for Bob.
You go.
Okay, we need to get some help from you, Bob, and ask you to opt the Route 21 now, just immediately prior to the CPAC run. Just prior to the CPAC run.
Okay, not now, but just prior to the CPAC run.
That's affirmative. And the idea there is to let it cool down so it'll hold.
Okay, understand.
Route 21 is Remote Acquisition Unit 21. It's the interface between the experiment computer and the CPAC.
Space Lab Marshal, for Ulf, we're standing by for the MSDR activity when you're ready.
Okay, I know.
Okay, Ulf, this is on MSDR procedure Foxtrot 100-5. It's step 2.6.
Okay. Wait a minute, let me pick up the procedure. Okay, I have it.
Okay. Page Foxtrot 100-5, step 2.6.
Okay. Got that?
That's all, just that step.
Okay. That deals with the instrument cooling system, just for confirmation, is that right?
That's affirmative. And we'd like you to note the noise level, please.
Pretty low. It sounds pretty good.
Copy that. And now we'd like you to...
just for confirmation, do you want me to kill the instrument cooling system, is that correct?
Negative.
The step 2.6 kills pump 2, is that correct?
That's correct.
Let me do it. Okay, tell you what happens. If you push the pump 2 interrupt and the pump 2 stops running, the delta P low light comes on, but as soon as you release the button, pump 2 comes on running again because pump 1 is dead. And for that reason, the automatic system activates the pump 2 immediately.
Okay, Ulf, we copy that. Appreciate your good work there, and we're finished with that operation.
Okay, once again, I was here on the module last night when the pump 1 died. And all of a sudden it stopped running. And the hardware says that pump 2 comes on to provide cooling, and that's what happened last night. And if I try to kill the pump 2 here by an interrupt, it works only as long as I push the button. As soon as I release the button, pump 2 comes online again.
We copy that, Ulf. Thank you very much.
Okay.
And Space Lab, we would like to get AV2 changed out if we can before the CPAC run starts.
Okay, we're working on that. It's going to be, well, in fact, it's going to be very close.
Yeah, we understand.
And how do you want this stuff routed, by the way?
Stand by. Not sure we understand your question, Bob.
Say again?
Not sure we understand your question.
Marshall Space Lab operations at 8 days, 13 hours, 53 minutes mission elapsed time. Approximately a half an hour remaining before we reacquire communications with the Space Lab through the tracking and data relay satellite. And during this AOS that just passed by a few minutes ago, the crew was just beginning its setup of the 201 experiment. Bob Parker was asked to check the Route 21 just prior to the CPAC. He's to let it cool down so that it will hold. That Route 21 is the interface between the experiment and the experiment computer. Bob Parker will be running right about now the passive experiment, the passive functional objective portion of experiment number 2, which is the CPAC. And Ulf Mirbold is scheduled to be readying to do the linear threshold portion of the 201 experiment. Just prior to our going LOS, Chuck Lewis voiced up a procedure for the crew to perform on the materials science double rack to see if they could get that pump working. There are 2 pumps that pump fluid through the ICS, the instrument cooling system. And on the previous shift, early on in the previous shift, that pump finally went out, leaving 1 pump. The material science double rack in the instrument cooling system, however, is still operating nominally. And nonetheless, a command was given to see if they could bring that other pump, which is not functioning at this time, see if they could bring it back up. But that procedure did not work. Of all the facilities in the materials science double rack, most of the experiments have now been completed. The isothermal heating facility, of course, has been inoperable for several days because of the short between the common supply system and the IHF in the line, which is between them, and which for about a day affected the mirror heating facility until that short was routed around so that the MHF could become operating again. All the experiments for the mirror heating facility have now been done, and all the experiments for the gradient heating facility have been completed. So those 3 furnaces, there's only 1 facility left. That's the fluid physics module, which is still operating. The others having either completed their experiments or the IHF, in that case, being inoperable. But the fluid physics module is still being used. There is, in fact, a portion of time set aside for this red shift coming up shortly, in which the fluid physics module will continue to be used for various unscheduled experiments. In the linear threshold portion of experiment 201, by the way, in which Ulf Mirbold will be the subject of that experiment, he'll be wearing that special helmet which has been described before. It's the helmet with the monitor over the left eye, which displays various images to the subject, and over the right eye is a camera which monitors the movement of the eyes. That's the eye movement in infrared or EMIR device. Ulf will be wearing this helmet as he's carrying out linear threshold. Essentially, he will be isolated. His eyes he will be essentially blindfolded with the helmet, and his ears will be cupped and supplied with a masking white noise. And then He'll be moved in the chair-like body restraint system in various axes and asked to report by use of the joystick his perception of motion and his perception of direction for each axis. Also during this AOS, Ulf Merbold expressed satisfaction that the Experiment 33, the metric camera, was during his particular shift, during this red shift. He was stating that he is looking forward to operating that experiment and taking some extra footage with the metric camera, with what film remains. That 300 operations, by the way, with the fluid physics module has been moved up. It's again part of that replanning effort by the team, which is next to the main cadre of Payload Operations Control Center personnel, where the communications links lie. Replanning has moved the operation of that fluid physics module forward. It was scheduled to be occurring in the next hour. However, that has been moved about 4 hours ahead. A little less than 20 minutes now remaining before we reacquire communications. At 8 days, 14 hours, and 3 minutes mission elapsed time. This is Marshall Space Lab Operations.
This is Mission Control Houston. The change of shift briefing with Flight Director John Cox, originally scheduled for 3:30 a.m. Central Daylight Time, will not be conducted. We're in the middle of a very long LOS period for the orbiter. Total LOS time will be 2 hours and 10 minutes, and we're still about half an hour away from acquisition through the Ascension Island Station. Mission elapsed time is 8 days, 14 hours, 20 minutes. This is Mission Control Houston.
This is Marshall Space Lab Operations, and we have just a little bit more than a minute to go before we reacquire communications with Space Lab. And currently the crew is supposed to be carrying out the linear threshold portion of the 201 experiment series. And they may even, at this point, be doing the caloric portion of the experiment. That's that functional objective in which a set of tubes are inserted into the right and left ears, and warm air is blown in one and cool air in the other, thereby warming and cooling the vestibular systems of either ear. And then a series of movements on the x-axis are carried out while the ears are in this state, and reactions are recorded. And we've just entered the AOS period for about 50 minutes.
Okay, thank you, John.
Space Lab Marshall for 49 minutes through Teeters.
Okay, got it. Okay, POCC, Space Lab's with you. We got Olson, the chair, all ready to go on threshold.
Copy that, thank you.
And I think we just finished CPAC.
Roger, thank you.
When 201 is ready to look at data, we'll give them a calibrate.
Stand by.
The sensitivity tower is up.
And the crew has completed its setup and also has finished CPAC.
Do you want to flow real-time TV and control the cameras? They're both set up, or do you want us to put them on the tape recorders?
It's following its setup of the 201 now with linear threshold.
Talking to us, I don't know.
Okay, Space Lab, this is Marshal Ops. We don't have place on the recorder, so we cannot record anything now. Later on we'll have real time. But do continue with the threshold experiment.
You don't have space on the recorders. We just...
correction. How many minutes?
Well, we put 30 minutes on the on VTR2, but VTR1 is a virgin tape.
Roger, we copied that. Okay, and then Bob, you can take what you need on AV1, over.
Okay, you guys want us to control the tape, so that was my question.
That's affirmative.
Okay, stand by just now. Hey, how do you read me?
Read you loud and clear, Ulf.
Okay, and does 201 have data? In particular, they have EOG data. We'll give them a calibrate in just a minute if they're ready.
Bob, we don't have KU-band downlink, so they don't have the data, but just continue. It will be recorded on board. Later on at about 14:30, which is about 5-6 minutes from now, we'll get the data down to the ground and tell you how it looks.
We can wait 5 minutes. We got plenty of time.
Whatever you want to do, Bob.
Stand by. Let's see. Then how long do you have us for the calorics? Okay, we're satisfied with the EOGs. We're going to do a calibrate and record it just to save some time here.
Okay, Bob, we copy that.
Oh, this looks pretty good. Oh, but, balance. Center. Center. Right. Center. Left. Center. Up. Center. Down. Center. Okay, going to mode 04. You should have nothing. Fine. And the joystick. What the hell is going on? What is it? Ah. Already. That's the right mode. Select the right mode. Yeah, you did. Right. Okay, we're going with X. Let me put the accelerometer. First one is direction, perception, and motion. Throw it forward. Can you see the joystick here? What is going on here? You can wait another hour.
Columbia, this is Houston, air to ground 1. Columbia, this is Houston on air to ground
Go
1.
ahead, Houston.
Roger, John,
Go ahead, Houston.
John, we suspect that you have a stuck-on heater in the gyro package in your KU band antenna. We'd like you to go to R15, Road Charlie, open, main B, KUA antenna heater circuit breaker.
Okay, run that by me again. R15, Road Charlie, and open KU band antenna.
Main B, KUA antenna heater, and that's because we think you have a stuck-on heater and a gyro package there, and we'll get back to you with a management plan.
Okay, main B, KUA antenna heater circuit breaker is coming open, mark.
We copy, thanks. We're turning air to ground 1 back to the guys in the back.
This is Mission Control Houston. The ENCO here in the Mission Control Center has verified that action has had the effect, the desired effect of reducing the temperatures that we're watching, and that gyro package, which provides stability to the KU band antenna, and mounted in the orbiter bulkhead fuselage. Mission elapsed time is 8 days, 14 hours, 38 minutes. This is Mission Control Houston.
All right, that finishes X.
And Space Lab, this is Marshall Ops. We like to sacrifice, if possible, the last axis for threshold and start caloric because of limited ground coverage. Over.
Roger, understand you. How much longer do you have in ground contact? See, we don't have a timeline today for comms.
Okay, Bob, we have till about 15 hours and 07 minutes, which is another 22 minutes from now. Over.
Okay, let me give you an abbreviated Z then.
Go ahead, Ulf.
Linear threshold is normally done in 3 axes, X, Y, and Z. Downlink data currently indicates that they are performing the Y-axis, which follows performance of the X-axis. Fubo Uncles has asked the crew to sacrifice the Z-axis performance in order to get on with the caloric portion of the 201 experiment. The caloric portion of the experiment uses the eye movement and infrared device, which monitors the eye and infrared and sends downlink data on the eye. But such downlink, such use of the E-mirror requires AOS. We have only about 26 minutes of AOS remaining. And meanwhile, the 201 experiment investigation team is monitoring the data, watching the various monitors on their equipment, and observing the E-mirror.
Well, I'm clear, Houston.
The E-mirror data is now flowing into the E-mirror equipment located in one corner of the 201 experiment investigation area.
Okay, say what it is. Pump Bravo to what? Alex? Center. Balance. Center. Right. Center. Left. Up. Holy smoke. Okay, well, we're not able to do it in that time, man. Center. Okay, that's it. How was that? Okay, go ahead.
Okay, in Space Lab, that calibration is okay.
A moment ago, you heard the calibration being carried out with the commands center, right, center, left, etc. These are actions that the subject calls out to the operator as the subject moves his eyes about, moving his eyes to the center and then to the right, back to center.
3 heaters off and Bravo to auto, over.
This action serves to establish the limits of the subject's natural eye movement.
Okay, I got it. Finally. And switches are in position.
Marshal up, this is PS1.
Go ahead, Ulf.
Okay, well, we are changing subject. There was one thing at 1334 which I should do for the MSDR.
Go ahead. Was there a question concerning that?
Well, Chuck told me only during the planning I should prepare myself to do something, but I'm not sure what he wanted me to do.
Okay, we copy that. And Ulf, be advised that that was already done. That was the test of the pump number 1 of the MSDR, over.
What was that?
That was the test of the pump of the MSDR, which you have already performed, over.
Okay, roger that, but the pump 2 is still on.
Yes, we know. And Ulf, you could help us with the calibration of the accelerometer by moving the accelerometer over a fixed distance back and forth. For instance, the distance from the helmet one side to the helmet the other side, over.
Okay, but it depends also on the time I take to move it. I'll do that for you.
Yeah, negative, Ulf. If you integrate that twice, you get back your absolute calibration, over.
Roger, I agree on that. Google, here comes the accelerometer from the end of the head to the front of the head, in X.
Okay, Ulf, from the edge. From where to where did you say?
From the end of the helmet to the front of the helmet, just from the structural bars of the helmet.
Yes, Ulf, we copied. Thank you very much. And we're looking forward to see the caloric nystagmus on Bob.
Okay, is that good enough for the accelerometer calibration?
Yes, thank you, Ulf.
Okay, wait a minute. We have to connect the EOGs quickly. Okay, well, we have Bob in the seat, and we are quickly checking out his EOG.
Reporting a checkout of the EOG. The electrooculograms, those are electrodes that are fitted around the eyes, one above and one below each eye, and one to the right of the right eye and to the left of the left eye. Total of 6 electrodes. About 16 minutes remaining in this acquisition of signal period. The downlink data indicates that the crew is carrying out now its calibration activity.
Marshal, we have a problem with the vertical UOC. Is it essential? Sure is.
Stand by, Ulf. And Ulf, can you have Bob make some up-down motion with his eyes or a calibration such that we can see whether it's workable?
Okay, he will move up-down right now. Give him an up-down. How does that look? There were a couple of up-downs.
Roger, Ulf, stand by. Take some time for the PIs to look at it. Okay, Ulf, yeah, this is good, and please continue then.
Okay. Okay, we are set. Okay, Marshal, speed advice, we started the caloric. 30 left, 44 right.
Okay, Ulf, we copy that. And, Ulf, if you think you can do it at one of these times you have to wait for the temperature, we would like you to copy something for the upcoming experiment on NO3 on the AEPI contamination, over.
To that. Now the data recorder is running, I cannot hear a thing, so I'll come back with to you.
Roger.
Okay, Bob, are you ready?
And Space Lab Ulf, we got the first nystagmus on Bob here.
Okay, that's amazing.
The caloric portion of experiment 201 is now underway. Bob Parker is the subject. He's wearing the helmet and EMIR data. Movement of his eye in infrared is currently coming down and indicating some nystagmus movement, that quickening movement of the eye when the vestibular system is subjected to certain stimulations, such as the one.
The caloric
Nystagmus sometimes occurs when the vestibular system is subjected to such conditions as Bob Parker is being given now, which is the cold and warm air temperatures. In the cold and warm air temperatures in the left and right ears, respectively. That temperature in the left ear will gradually be dropped to 15 degrees.
The advice to go for 20 left, 44 right.
We copied that, Ulf, and looks like the nystagmus has grown on Bob during the mission, which is really very nice result.
Okay, that's interesting. Now, let me pick up something to write on.
Once that set of temperatures for the left and right ears have been accomplished, then the next set of temperatures is put into effect.
We're ready to copy.
Okay, Ulf, here's Chuck with a list of things to copy.
Okay.
Okay, Ulf, these are 8 steps for Bob when he runs the AEPI contamination FO at 1525. He should use camera Charlie.
Go ahead.
He will be using camera Charlie on the orbiter and procedure TV31 from the orbiter TV book.
Go ahead.
He should set it up according to TV activation and align camera Charlie with the orbiter x-axis.
With the x-axis, like X-ray, is that correct?
That's affirmative. He should pan left.
Okay.
He should pan left 60 degrees and tilt up 4 or 5 degrees.
Okay, turn left 60 and tilt 45.
Roger, tilt up 45. Then zoom out full and focus far max.
Okay.
Then he should verify that the bright vehicle is not in the field of view.
Okay, go ahead.
Record data on AV1.
In Space Lab.
That's affirmed.
Okay, what else?
Then deactivate camera Charlie per TV31.
Got everything.
That's it.
Is that everything?
That's
okay.
all of it.
Contamination. Okay, Bob, whenever he does EPI at 1525, use camera C of the orbiter. According to TV31 of the orbiter TV book, to the TV activation, align camera Charlie with orbiter x-axis, turn left 60, tilt up 45, zoom up full, focus far max, verify bright vehicle not in field of view, record on AV1 and deactivate.
That's affirmative. Thank you. Good show.
Okay.
And Space Lab Wolf, also be advised you can run this AV1 to the end for that experiment, all the way down to the end.
Okay. Are you recording on the calorics here in real time?
We have
Or is there anything going on?
Yeah, sure. We have beautiful data on the ground, and in a few minutes we have only the low data rate on orbit because we go LOS in 5 minutes about.
Okay. Now we are ready for 20 left and 44 right and to the dynamic part.
Roger.
By the way, Bubba, our strategy was great.
I'm sorry, Wolf, we did not copy that one.
And Space Lab, you can ignore the 20 error messages. We've turned them off.
For a few minutes there, some voicing up of procedures from Chuck Lewis to Wolf Mirbold in the operation of the atmospheric emission.
Left and 44 right.
We copied, Wolf.
Of the atmospheric emission photometric imaging experiment. That's the AEPI, NASA experiment number 3. Basically, in those procedures, Wolf Mirbold being told which camera on the orbiter to use.
How's the AMIR, by the way?
Wolf, the AMIR was good. We don't have AMIR at the moment anymore. It's going to be recorded, or the EOG is going to be recorded on board. Over.
Okay, can we really record AMIR on the high data rate recorder?
That's negative, Wolf.
Will you get it back, or is that impossible?
The AMIR cannot be recorded on board. The EOG, of course, can and will be now. So it's still good to continue.
Okay, and you won't get AMIR back on the ground?
That's affirmed.
Okay.
So we got a lot of AMIR on the ground till about a few minutes ago, till about 6 minutes ago, and it really looked very good.
That was the dynamic part for 15 left and 44 right, and now comes the changeover 44 right, 20.
Wolf reporting that the first set of temperatures has been reached, with the left ear at 15 degrees Celsius and the right ear remaining at 44 degrees. Once that minimum and maximum degrees of temperature have been reached, they are switched over. The warm-cool process is reversed, and the left ear temperature is raised to 44 degrees Celsius, while the right is lowered to 20. Wolf Mirbold will give a maximum of 3 minutes for this reversal of temperatures to occur before he begins the X-axis movements on Bob Parker. And following this reversal of temperatures, once the right ear has been lowered at 20 degrees and the left ear at 44, following that, the temperature of the right ear will then be lowered to 15 degrees, just as the left ear had been in the previous run. After each of these sets of temperatures are reached, X-axis movements, as we mentioned, are given to the subject, Bob Parker, and he reports any sensations of motion. And this is Marshall Space Lab operations at 8 days, 15 hours, and 14 minutes mission elapsed time. We have entered again into an LOS period, but we'll be picking up the Space Lab again in about another 14 minutes or so as it passes over the ground station at Guam. During this last AOS, the crew was very actively involved in the 201 series of experiments that they had been given to do. In this, the extra day of the mission, the 10th day, as the crew has been asked to do a linear threshold and the caloric portions of the 201 vestibular series of experiments. They had nearly completed the linear threshold that was to have been done in all three axes. They were able to complete X and Y and were about to proceed with the Z axis when the Payload Operations Control Center asked them to not do that and to proceed with the caloric because there were only a few minutes of AOS remaining. And they wished to get some good E-mirror data on that eye movement in infrared. E-mirror is a type of data that is high rate in its nature, and it cannot be recorded on board. It can only be recorded on the ground, and therefore requires AOS. And so the caloric portion was carried out with Bob Parker as the subject, and the first set of temperatures having been reached, and just as we were going into LOS, Ulfmir Boll was going to reverse the warming and cooling process of those ear tubes. But since we were going LOS, the E-mirror would not be coming down any longer. However, Vubo Ockels reported that the 201 investigation team had already received some very good E-mirror data, and that the crew was to continue on with caloric and to have the electrooculogram data recorded on board, which is a lower rate of data and can be recorded on board, whereas the E-mirror cannot. And so that experiment continues, and it is a
Okay, I'll do that. I'm just putting a fresh tape in AV2, so AV1 is the only one you have for the time being.
And Space Lab, this is Marshall Ops. We were with you for about 6 minutes. And Ulf, I have information for you for how to use the metric camera. Over.
1 second. Okay, Bob, you got the orbital 1 on AV1. Okay, well, we have only one orbiter here, is that correct? Yeah, we do. Okay, that's the item 8, okay. Okay, Uwe, I'm with you. Go ahead now.
Okay, Ulf, you probably need a little piece of paper to copy if you have that.
Okay, I got it.
Okay, point number 1 is do not use all the film. Leave about 10 pictures. They need that for calibration on the ground. And that corresponds to a MAC remain reading of about 70. Over.
Okay, pass remaining 70.
Roger, and then step 2. For this passes on Europe, use f-stop 5.6 and a exposure of 1/250s and suggested 60% overlap. And the exposure time and f-stop are already set.
I missed the last point. 5.6, 1/250, 60%, and the last thing, please repeat that.
That these f-stop and time is already set in the camera at the moment. Over.
That's great. Okay. Fantastic. So we need only to flip the switch to 60% and start the timer.
Yes, and just do it according to the little decal on the camera. Also be reminded, if you want to take a picture, that it takes 15 seconds from timer start to the first picture. Over.
Sure, okay. Thank you.
And then, Ulf, I have here time information on 2 revolutions for Munich and for a Bremen observation. And first I will start with the times for Munich. Over.
Go ahead.
This is ref number 141. You approach the coast of Spain and Portugal at 08 day, 16 hour, and 32 minutes sharp. You are at Munich at 16 hour.
Hold it, stop, I missed that. Portugal, what was that?
08 day, 16 hours, 32 minutes sharp.
16 hours, 32 minutes.
Roger. You're at Munich at 16 hours, 37 minutes and 30 seconds. Over.
Okay, Munich, 16 hours, 37 minutes.
And 30 seconds. 37 minutes, 30 seconds.
Got that.
Okay, Ulf, and you should stop that pass or whatever you do at 16 hours and 38 minutes sharp.
Stop 16 hours, 33 minutes, 00 seconds.
Yeah, 38 minutes. 38 minutes, over.
38 minutes, okay, got that.
Then for Bremen, that is in ref number 144, you will pass first over the coast of Great Britain, and that will be at 08 days, 21 hours, and 13 minutes.
Okay, Great Britain will be at this mission day, 21 hours and 13 minutes.
Roger. Pass over Bremen will be at 21 hours, 15 minutes, 30 seconds. Over.
Bremen will be 21 hours, 15 minutes, and 30 seconds.
That's affirm, and you should stop that run at 21 hours, 16 minutes sharp.
Stop at 21 hours, 16 minutes sharp.
Roger. And on those passes, as I said before, you can take pictures as you want. You should bear in mind to keep a log of the pictures you take, because we do not want to use all the pictures, as I said before. Over.
Okay, we will do that. And yeah, I think that's all I need for the time being.
Sounds good.
The only question I'd like to ask you, is there any information on the forecasted weather in Europe?
Just stand by. We will get that for you. Over.
Roger. We'll find it out pretty soon, by the way.
I guess so. And Space Lab Ulf, from George Todd, you have a wish for gutes Licht.
Say again?
Gutes Licht from George Todd.
Oh, okay, thank you. CC Space Lab.
Go ahead.
I was unable to do that AEPI thing for two reasons. First of all, I got up there and discovered that the camera was dead in the sun. The second thing is, it's impossible, and you guys ought to understand it by now, it's impossible to do a procedure on 2 minutes' notice that was never done before.
Copy that, Bob.
Columbia, this is Houston on air to ground 1.
Go ahead, Houston.
Roger, John, we'd like to do some troubleshooting on that KU antenna gimbal heater. If you would go to R15 Road Charlie and reset the circuit breaker, which is main B KUA antenna heater. We'll keep looking at it, and we'll call you if we need you to open it up again.
Okay, it's closed. Mark.
We copy, thanks. We'll give the loop back to the guys in the back.
No CC, Space Lab.
Loud and clear, Bob. Go ahead.
Okay, you copied my comments on the N3 contamination, which didn't get run?
Roger. We sure did.
That's twice, those AEPI guys are giving us attitudes that just don't seem to work. I went upstairs. I don't know if I could have done it anyway, but with regard to my other complaint, but I went upstairs and camera C was in the sun, and this was after 15:25.
Yeah, we understand both complaints and agree with them, Bob.
Second thing is, how about this? There was an N2FO13, at least on the 133 Alpha message, scheduled at 15:20, but I never got a real T0 or instructions on that one.
Bob, that one is now scheduled for 16:20, and we're ready to talk about that one now. You didn't miss it.
Okay, hang on, let me get my book out. Okay, coming up on 16:20.
Okay, Bob, this one is exactly like the first one that you did today back at 13 hours and whenever it was 15. They liked the way that first one went. They liked the way the first one.
Okay.
They liked the way the first run went. Everything is exactly the same except for the T0 time, and we'll give that to you in a second.
Okay, and I had to guess it being daytime, and now I'll laugh that this was MTV inhibit as well as the PCF 69=0, but I assume that was right.
That's firm.
You're going to want 2 runs to 17 this time as well?
That's firm. Roger, Bob. That is correct, and the T0 time is 8 hours, 20 minutes. The exception monitor, STL, same as the first one, Echo 06.
Okay, Echo 06 and 0820.
That's firm.
It's not quite the same place in the orbit, huh?
That's firm.
Okay. MCOCC Houston. Left.
Calling us or Houston, Bob?
CC space left.
Copy loud and clear, Bob. How many?
Yep. COCC Houston. Space Lab.
Go ahead, Bob. Give it a try.
Okay, good to talk to you again. Let's see. What's the possibility of running this CPAC as 2 back-to-back FOs instead of doing the whole restart? Any particular reason one way or the other?
Stand by. Either way would be fine, Bob. Go ahead, Ulf. Copy.
Okay,
Okay, Wubu, can you check with 33 the filter another time? Right now we have the Bravo Foxtrot filter installed. I checked that, Ulf. As far as I know, there's only one type of filter on board, over. Oh, there are two filters on board. Yeah, that's affirmative. And the lens cover. No, wait a minute. Wait a minute. There is one in this little box here. There are two filters. One is stowed, and that is 3 Bravo Sierra, and that means the 3 Bravo Foxtrot filter must... And Space Lab Marshal Ops for Ulf, you have two filters on board. They both the same, and they match the black and white film you want to use, over. Okay, do we have the black and white on in that magazine now, which is called 3 Bravo Foxtrot? Well, Ulf, you probably have to ask Bob. We did not put it in there. Okay, Bob did, but I mean, the magazine is a black and white magazine. Yeah, that's affirmative. Great. Say again? That's great, and John gave us already the minus D-native attitude, so we are all set. Very good, Ulf. And be reminded that whatever you do, you keep a picture count so that you know how many pictures are left, over. Yeah, sure, we'll do that. What is the weather like, Ulf? Hey, what was that again? What is the weather like, Ulf? Clouds, yeah. Hey, John, if you look out of your window, right in towards the nose, there must be a big buildup. That's what I see. Gee, that looks real terrific. Yeah, I wouldn't like to be in that moment. And Space Lab, Marshal Ops, did you had a look at or receive the message number 139er? Well, we were so busy, we didn't check it. But I have a few minutes. Let me go and see whether there's a message. Roger, and I'm sorry if you guys make it too busy, then just give us a call. All right, now there's the time to look for it. Wolf? Yes, go ahead, Wolf. I've checked for your message. We haven't got it yet. Okay, we'll check it here. And Space Lab Marshal Ops for Ulf, that message 139er was uplinked as far as we know about 4 hours ago. Okay, then we check again. But don't miss your pictures, right? Of course not. And Space Lab from Marshall, no response necessary. That message 139 came up together with message 142, which was the latest weather report update. Okay, well, we are trying to find it. Okay, well, we got the message. All right, and if you have any ideas or suggestions or whatever, we would like to discuss it, of course. Okay, we'll come back to you. Sure. And, well, you don't get all the way to Holland here, but I guess about one picture would cover the whole country, isn't it right?
I think it is. One picture is about 185 kilometers in one dimension.
Oh, that's about correct, Ulf, and I must confess Holland is not all that much bigger.
Well, it doesn't matter. It's a nice country.
Thank you. And Space Lab for Marshall Ops, just a weather info. You probably see a lot of clouds.
Yeah, right,
Okay. We were just thinking that you see a lot of clouds over Spain. Is that not true?
Okay, PLCC Space Lab. Well, we finished that metric camera pass. It was a rather short and not too good one for the weather.
We copied that, Bob. You probably have taken in the order of 30 pictures, which means you have about 60 left, over. Space Lab.
Too good, but we got some. Nice pictures. Okay, we'll try it. Okay, well.
Space Lab, Marshall. Ops through Aurora for 2 minutes and 57 seconds.
Okay, we're with you.
Okay, Bob, we've been trying to get some information up to you. Been awfully busy with the air-to-ground loop, but we've got a couple of PCAP changes that I think you'll like, and we can voice them to you now if you're ready.
Try me out.
Okay. What we've done is to clear out the time currently until 19 plus 30 for what you guys want to do. We're kind of assuming that you wanted to do some fluid physics, and for that reason, we've got some fluid physics experimenters available if you'd like.
Okay.
Also, Bob, for you, the N2 Charlie Foxtrot, Romeo Foxtrot, the battery disconnect for CPAC is delayed until 19 plus 10 through 19 plus 15, and the reason for that is to get it into HRM coverage. We're hoping that in the event you do fluid physics, you'll set up a TV-21 for us so we can watch you on the ground.
Roger.
And that'll...
Okay.
That'll take you through 20 hours.
Okay, now, am I to understand that the N2 FO13 at 17, about 50 is gone away?
That's still there, Bob.
Okay, that's again 217. And what's the T0 time?
Stand by, we'll get that for you. Space Lab for Bob. The T0 on that run, Bob, is GMT 10 hours, 40 minutes. And we're going to enable a voice loop to let the PI give you some instructions prior to that time, probably just after 1800 hours. Also, we're wondering anxiously how the last two CPAC runs went. Space Lab Marshall through TDRS for 48 minutes, and we've got some information on a following interesting RIV, if you guys have any film left.
Okay, go ahead, we're ready to copy. You're a little noisy at the moment.
Okay, looks like Rev 145 will put you over Paris at 22 plus 46, and over the Swiss Alps at 22 plus 48 with improving weather.
Okay, I understand. Thank you.
And we're interested in getting some real-time TV as soon as you guys are ready.
We're just setting that up, and I need a time for my next CPAC.
Copy, stand by.
Marshal off.
Go ahead, Ulf.
Okay, we have one camera set up. It's camera 2.
Okay, Ulf, we've been talking down here. Noticed, we think that you may have gotten the cables interconnected there, and you've got camera 1 mounted where camera 2 should be, and vice versa. Makes a difference because when you set up for one camera to go straight down and the other on the tape, it's a little confusing for us. You might check that out and see if we're correct in our assumption.
We can figure that out, that's for sure. Camera 1. Camera 2 is the one that is on. Camera 2 shows the inside of the module. And camera 1 is here for the FPM. We do not always stick to what camera 1 is in terms of 1 or 2 in the setups, as long as we know which one to put on the VTRs. We do make sure, because we never disconnect, that we don't put camera 2 on the actual camera on the camera 1's cable, because we know that gives a problem. Marshall, do you read us?
Yeah, we were just talking it over down here. The only problem is that for us, when we configure the VAS from the ground, apparently we've been configuring it wrong.
Well, we can reconfigure it for you pretty easily. We normally grab the first available camera if I want to show the FPM, and there's a camera hanging around. I take the first one I can reach.
Understand.
Sorry for that, Chuck. If you want me, we can switch it over. It's no problem.
Well, we don't want to take time away from the fluid physics, but it sure would make life easy for us.
Okay. I'm here to try another run for John Petty. But I'm a little bit lost here to run his 329 Charlie. Is John somewhere around?
I am enabled. Hello, Ulf. John here. Now...
Hi, John. Break. Before we get into that, COCC, I have to have a start time for this upcoming CPAC run.
Coming up. Space Lab Marshal for Bob.
Let you go ahead.
Okay, Bob. Your the model number is 1. Model number 1. T0341, 10 hours, 40 minutes.
Yeah, but wait a minute. What about there's one scheduled at on my PCAP also at 1750 approximately MET. And then to FO13.
That one has been canceled.
Oh, okay.
Sorry, we didn't get that to you.
Okay, now give me my FO1 time again then.
Okay. GMT, day 341, 10 hours, 40 minutes.
Okay, and that's just going to be a standard FO1.
I got a PCF for 2 for you. PCF 25 equals 1 and 69er equals 0.
Okay, 25 equals 1, 69 equals 0.
That's affirmed.
Anything else?
I'd like you to go to Manual Ops 02 Delta Tango -18, steps 1 through 11, except 6, 7, and 8.
And Manual Ops 02, DT, detail page 18, steps 1 through 11, except 6, 7, and 8.
That's affirmed. And on O2A, we'd like you to inhibit Echo Bravo Alpha, Papa Whiskey Romeo, Delta Golf Papa, Mike Tango Victor, Mike Papa Delta, and Hotel Victor Charlie.
Who's that leave?
Leaves the diagnostics only.
So I thought DGP was in that list. Anyway. Okay, and be advised for CPAC that the last run I got a depth 00 at a time of 084243. And when I checked, the CPAC depth had knocked itself.
Copy that.
Okay, and where do I find N2 Charlie Foxtrot Romeo Foxtrot 15 for a procedure?
Stand by. Space Lab for Bob.
Would you go ahead?
Okay, take questions one at a time, Bob. The inhibits on O2A only inhibit the exception monitoring. Also the...
I know.
Okay, Charlie Fox Romeo Fox procedure is the CPAC deactivation procedure, which you will find on Delta Tango 20.
Okay, I found the deact. I just couldn't make the acronym work out at all, so I was beginning to wonder. Okay, and that's between 1910 and 1915, and we'll coordinate that one.
That's firm.
Okay, I'll sign off.
Okay, one more thing. I was mistaken when I told you we were ready for real time. That won't be for a little while yet, but you've got AV1, which you can put it on as long as we make sure it gets changed out in time for the TV-18, which is now scheduled for 20 hours, 10 minutes.
Okay, what's TV-18 for?
102 FO4.
Oh.
Hey, Chuck.
Go ahead.
329.
Come back to fluid physics.
Well, what is the problem, Ulf? First of all, are you receiving me?
Yes, I'm reading you.
Okay.
I'm reading you.
Can I just...
I'm set up for you. Okay, go ahead, John.
I'm sorry I didn't read you.
Is that any better?
Okay. Well, now, look, Ulf, in 329 Charlie, I wanted to try and not do too much, but really just to take points A, B, C, and possibly D, and break the zone, certainly when you get to B, at constant volume. In other words, go to the settings of B3 and then break the zone by just withdrawing.
Okay.
Now, when you have done that, could you set the vibration of the rear end plate to those figures given in the procedures, and then break the zone again with the vibration running? And if you remember, at Harrow, we found that the zone was more stable. Now, I want you to see if you can actually prove this effect, which we could call the Merbolt effect. Now, in setting up 329, it will be necessary to adopt the procedure that was used by Byron in my second run, namely to withdraw the front end plate to approximately 40 and the reservoir, and then, are you copying this?
You're a little bit too fast to copy that all down.
Okay, well,
Stand by a second. John, we have, it happened by coincidence that we have the 5 Sandy Stokes oil with tracers, and I'm using that. I hope the tracers do not bother you.
No, they do not bother me for this experiment because, in this case, we are doing more phenomenology than direct measurement. But we will get data out of this. That I am sure of, even with the tracers present. Now, what I would like you to do in the setting up is, as I have said, to set front end plate 40, speed.
Hold it. Stand by. Okay, I grab the piece of paper and write it all down. Just a second.
Speed 40. Sorry, setting 40, speed decimal 20. Reservoir 40, speed decimal 20. And that just withdraws the front plate from its zero position. To inject liquid, set front end plate 3636, rear reservoir 35.6.
John, you are too fast. Start all over from scratch. Okay, the first thing, which point is that? The 40.
The first point is just taking the front end plate backwards in a dry condition.
Okay, that is separation, and that is 40 and 40 for both.
Then the second point is 36, speed 0.10, decimal 10. Reservoir.
Okay.
Reservoir 35.6, 35 decimal 6. Reservoir speed decimal 11. The aim here is to introduce liquid onto the front end plate slowly.
Okay, and say again the front plate speed.
Sorry?
What was the speed for the front plate, for the feeding plate?
Decimal 10.
For the reservoir is decimal 11.
That is correct.
Okay.
This will introduce about 20 cc's of liquid onto the front end plate and should wet it all over. You then, with your own choice, choose your own settings to bring the front end plate to touch the rear end plate. That is, the liquid to touch the rear end plate, and the meniscus is then made. Then proceed. Then proceed to point A3, alpha 3.
Okay.
Then proceed straight to beta 3, B3. And at B3, brake zone at constant volume.
Okay, I'll do that. I repeat, we separate 40-40, then we go to inject, and we inject front plate 30.6, reservoir 35.6, speed for the front plate 0.1 and reservoir 0.11. After that, we merge the zone, or we merge the liquid which is on the front plate with the rear plate. And when that is established, go to point A3, from A3 to B3, and brake at B3 with constant volume.
That is correct. Then remake.
And then will be... Okay, go ahead.
Then remake zone. Remake zone.
Okay.
Set vibration going. And then try to brake zone a second time. And the purpose here is to find if the two settings are different.
Okay, what would be the difference between the two brakings?
Well, if what we found at Harrow is correct, we would find the zone more stable with the vibration and not less stable as might be expected.
Okay, in other words, you want me to write down the, let's say, distance, separation distance, for the first braking and the same for the second braking, and the difference being for the second braking there will be vibration going on.
That is correct. And
do you have any specific frequency for this oscillation?
I think probably the best one to use is a frequency of 2 hertz, 20 hertz, an amplitude of decimal 4 millimeters, and a ramp of decimal 5.
Okay, copy that.
Okay. Can I just check one figure in the second setting of the introduction of the liquid? I just want to check a figure back, because I've had it pointed out that you thought it was 30.6 as the front end plate setting for the second point of the procedure. It's not. It is 36 decimal 36.
Okay. Now I'm confused now. The front plate setting is 30.6. That is 30.6. Is that correct?
That is incorrect. It is 360 decimal zero. 36 decimal zero.
Okay. Got that. So it is 36.0.
Yes, definitely. Now,
but that means that there is only a very small amount of oil injected.
Correct.
4 cubic centimeters.
That is correct.
Okay. We'll try what we can do. I will set up the video here, and I'm not sure whether Marshall can downlink it in real time. That would be great. If not so, then I'd like to get some advice from Marshall Ops whether I could put it on one of the recorders.
Stand by, off. Space Lab Marshall for off.
Chuck, go ahead.
Yeah, I understand you're looking for a tape recorder you can record some video on. You can have the rest of AV2, provided it gets exchanged by 20 hours and 10 minutes.
We'll make sure that we do that for you.
Okay, and Vubo passes up the fact that you have 70 frames remaining on 33 camera.
We took approximately 25.
Copy that, and you have 70 remaining.
Thank you. Marshall Ops, we got a 02A IU 5-volt power, 35 error message.
We see it, off.
That's the CPAC problem here.
Space Lab Marshall.
Go ahead, Chuck.
Oh, we've been looking at the analog video tape management situation down here, and it looks to us as though if you'd like to use some of the tape for video from the fluid physics module, at this point it looks like it would be a lot better if you put it on AV1 instead of AV2, as we told you earlier. And as we also told you earlier, we'd still like to have that changed by 20 hours, 10 minutes if you run it down to the ground.
Okay. I'm putting it on AV1.
That's super. Thank you.
Chuck, the tape change due at 20 hours, 10 minutes. That will be AV2 or AV1 then?
AV1.
Okay, then we correct that.
Yeah, it should be completed by 2010.
Okay, do we have real-time television right now?
Negative. Still waiting on KU band.
Okay.
329 PI, Space Lab. I received you.
Yeah, I'm fighting with a little bubble in the office of the FPM.
How big is the bubble in relation to the amount of liquid?
Well, I don't see the air inside the tube. That's the problem here.
Might be sensible just to leave it for the moment and see if it comes out on the first vibration.
First of all, I need to establish a zone. For the time being, there's air coming out.
Okay.
Okay, we got something, but the amount of oil is extremely small.
In which case, if you wish, you can leave the two speeds at the same numbers and go to front end plate position 32, 32 decimal, and the reservoir position. Mr.
Wait a minute, John. I'm still at the 36 and 35 position, and I have not merged the oil to the opposite plate. But on this huge titanium cone or whatever material it is, it's almost not noticeable. It's a small amount, but I will try to go now to 1 millimeter and form a little bridge.
Okay, Olf, I've copied you.
As far as I can tell from Madame Rodot, it is in the order of 2 cubic or 3 cubic centimeter oil, what we have now.
I understand. In which case, I think we'll go to point alpha 3 straight away and see if there's too much air in the system or whether it can grow to a reasonable meniscus.
Break. Space Lab Marshal, we've got 20 seconds before LOS. We're a little concerned about the CPAC IU depth. If it's on, we would like you to turn it off. We'll see you again at 1900. Space Lab Marshall through Aurora for about a minute.
Roger, go.
Bob, can you confirm that the SWA cover is closed after that last observation?
I know it's still open.
Yeah, we need to get it closed, Bob. Thank you.
Okay. And POCC, This FO1 has, I've gotten no depth messages, but it's continued to run well past 480. It's now at 534 seconds.
And we'd like you to terminate seatback operations according to the normal shutdown procedure, Bob.
Yeah, but it should have shut itself down at 480, shouldn't it?
Yeah, we think there's a problem, so we'd like to have you do it now.
Okay.
And you can ignore the 21 messages.
How we have them?
Space Lab, Marshal Ops for 04 Bob.
I think it means checking the pointing with respect to the sun. When you go to the solar attitude there, that's one of the solar experiments that has its own sun sensors as well. Check to make sure that we pointed in the right direction. One of the questions is twisting of the pallets and the payload bay. It's got little sensors that are positioned, you know, so that it sees the shadows and the right angles and so forth. Well, it does it itself and just puts out a number for us down here. I think it's warning you that we're going to look at it and tell you you did or didn't do good on your pointing. Feel ashamed.
What looks nice, John?
329 here, Ulf.
What looks nice? I'm asking you. Oh yeah, that looks very good.
What actually have you been able to do while we were LOS, Ulf?
Well, for a long while I thought it would be a good idea to send that whole thing to Bordeaux and fill it with red wine. But I changed my mind. I think space is better.
Okay. Now, have you been able to get the...
We're supposed to talk to these guys again, John. The comps are awfully rowdy today, isn't it?
Now, let me ask you, did the simulator any better in terms of reliability? Did they become better in these days? Yeah, sure. that one looks pretty good, the SpaceX.
Looks good, but doesn't do anything.
And Space Lab, this is Marshall Ops. We're with you over Bermuda for about 4 minutes. Over.
Okay, good to talk to you again.
Good to talk to you.
Yes, and Bob and Ulf, some info on that metric camera opportunities. It's a pity, but the Ref 145 Paris and the Swiss Alps cannot really work. That's beyond the time when we have to stow that equipment. But basically the whole period before that, and I don't know whether you have that, I will give it, you are in -C nadir. So, and you have 70 pictures left. So I will give you the times when you are in -C nadir now. It is from 20 hours and 50 minutes to 22 hours and about 20 minutes when you have start to stow the 33 camera. Over.
Okay, 20, 50 to 22 hours, roughly. That is -C nadir, and we can take the rest of the film.
Yes, I hope you can manage that. There's a 104, which is recruitment for Bob. It, of course, needs a little assistance for you, Ulf, but I guess you can manage that, do the other things at the same time. Over.
Say again what the 104 was, we couldn't hear you.
Okay, the 104 is a recruitment on Bob, a static recruitment, and Ulf only needs to support you probably to put the needle in. By the way, the position of needle is the same as you did the last time. That was really good. 7 millimeters to the left. Over.
So it's a recruitment on me, but not on Ulf, right?
That's affirmed.
Okay, copy that.
Space Lab, for Bob, we'd like a status report, if you would, on how that CPAC deact went.
Okay, yeah, the ECAS just stopped talking to me. It wouldn't accept, what is it, the item 1113 or the item 14. So eventually I had to go over and just use the switches and turn it off. The depth was operational, and Route 21 had given me no messages. So there was no indication of any problem. It's just that apparently the depth and the ECAS stopped communicating with each other, I have to assume. The only indication I had of a problem was that the count continued on, the delta T count continued on beyond 480.
Say again, Bob?
The only indication I had of a problem was that the delta T count continued on beyond 480 seconds.
Yeah, we copy that.
Well, I just had to shut it down using the manual switches.
And that's fine, Bob. And now we'd like to know how the deactivation went, the Delta Tango 20.
I did not do that because I thought we were waiting to do that through Tetris, which you obviously didn't have.
Okay, that's fine, and looks like we've got data now. We'd like you to do it.
Okay, I'll press on with that. Okay, on my mark, I will be holding the bat cells to disconnect for 1 second. And SID 3079 is showing off.
Copy that.
Spacelab, I guess that Ulf reported 22 hours as the end of sea local vertical. That's not correct. It is 22 hours and 20 minutes. Over.
CC, copy.
Negative copy, Bob.
Okay, on my mark, I turned off the bat cells and the 30 SID 307.
Yeah, we copied that 3079 off, and the bat cells disconnect at 19 plus 32 plus 50.
And is the POC notified?
Say again, Bob.
The POCC notified?
Stand by, Bob. Spacelab, Bob, if we understand your question correctly, we passed the time information over to CPAC. In fact, they were listening, and if that's not your question, then we're not quite sure. You might repeat it.
Roger, the end of the procedure says I'm supposed to notify the POC. I wanted to know if the POC had been notified.
Oh, that's easy. It sure has been.
And Spacelab, Ulf, I just still had a remark for you. You said at 22 hours, the end of the minus E nadir. That's not correct. You can go until 20 hours and 20 minutes, 20 minutes, over.
20 hours, 20 minutes. We are talking about what, Wobo?
Are we talking about the total period you have where you can use the last 70 pictures which are there on the metric camera?
Okay, wait a minute. 20 hours, 20 minutes?
Right, that's about the latest where you have to start immediately stowing that metric camera.
Okay, so we better run it now. Yeah, but we are looking to the sun.
Spacelab Marshall for Bob.
How's it go?
Can you verify the BAT connect indication on the DDU page moved from on to off, and can you remember the time when it happened, please?
The BAT connection where?
On the display. O2 Sierra.
I was reading 3079 when I did that, and I was turned it off at the panel.
Copy that, Bob. I guess what we were hoping you might have seen was a transition on the O2S display, a momentary one.
Stand by. I'm looking right now. I'm looking to see which procedure I actually used. Stand by.
Spacelab for Ulf, we're ready to flow real-time TV if you guys are ready up there.
Anytime, Mark.
Okay, thank you.
Okay, it looks like the procedure I used, POCC, was the emergency shutdown procedure rather than the deactivation procedure.
Copy, Bob, and if you would, at this time, we'd like you to do the Delta Tango -20.
Okay, well, all that's left to be done there then is going to be pull the circuit breaker and turn off DC2, correct?
Stand by. Negative, Bob. We'd like you to go back and start the deactivation procedure from the beginning and just run it through to the end.
Okay. I'm going to go to chargers enabled at this time.
That's affirmative, and we'd like you to monitor O2 Sierra also, please.
Okay, that's coming up. Oh, I suppose it will show bat cells off instead of on. Shows bat cells off currently.
Copy.
So I'm going to skip to step 5 and go to inhibit.
Are the chargers enabled, Bob?
Chargers are enabled.
Copy.
I'm now going to step 5 to chargers to inhibit. Higher depth is still off. I'm going to pull out the circuit breaker. And I'm turning off DC2. Okay.
And could you confirm step 3, please?
Well, step 3, the bat cells at step 2 are already off, OFF.
Space Lab Marshal.
Go ahead.
Bob, we've got a few minutes here for before we do this 102FO4 activity, and Larry Young would like to chat with you a little bit about some aspects of it, just to make sure some additional steps are incorporated in the procedure. At your call, we'll bring him up on the loop.
Before he comes on, let me quickly report to you that we have the 21 display up here, and we are at the sun. And as far as we can tell, the instrument works not nominally as far as ECAS goes, but I think the hardware is okay.
Okay, we're working with non-ECAS timelines, and that's why you don't see that.
Yeah, but at least we are perfectly on the sun, and we have everything on, reference sources on, and shutters are open and closed, and so on and so forth. It seems to be okay.
Copy that.
Okay, and if the PI feels he has to talk to us about FO4, go ahead.
Space Lab, good morning. This is 102 Young. Do you copy?
Hey, Larry. Go ahead, POCC.
Right. Space Lab, this is quick review of the modifications to the FO4 awareness of position that Dr. Money voiced up earlier. First, you should begin with the tight straps arrangement. Begin with the tight straps arrangement. Second, if the subject does not lose if the subject does lose awareness of position, of limbs, or of targets in the tight straps position, then do not continue with the loose position, but instead change subject from the PS to the MS and repeat. Do you copy?
Roger.
And finally, Bob, on step 3, where after putting on the blindfold where it says don't move, Ken would like you to relax all muscles. I'm sure you'll have no difficulty with that.
Yeah, we saw that also.
Okay, those are all the instructions that I have remaining from Dr. Money. Do you have any questions, and do you think you're going to be able to stay awake through it? Over.
If I don't have to do it, I don't think I'll have any problem.
If Rolf does in fact lose all ability to point to targets or locate his limb positions, then the instructions would call for switching subjects, and you might have to do it.
I'll make sure he doesn't.
We copy that. Look forward to seeing you at Dryden.
And Space Lab Marshal Ops for Ulf.
Hey, Bobo, yeah. I'd like to talk to you also.
Okay, Ulf. First, there was still some confusion here whether you copied the times correctly when we are in the attitude -C local vertical. That time is 20 hours and 50 minutes through 22 hours and 20 minutes.
Okay, that sounds much better. Thanks a lot, Bobo. 20 hours 50 to 22 and 10, I think. Bobo, are you still with us?
Yes, sure, Ulf.
One short question. Which data sheets are we supposed to use? I don't think they put enough data sheets in these books for us. So how about telling us specifically which set of data sheets and questions we're running through for FO4?
Space Lab Marshal, we're 3 minutes from LOS. Just a reminder before we go over the hill, if you've not exchanged the cameras as we discussed a little earlier, we'd like you to do that at this time so that the recording of 102 will be going on the right recorder. If you did do it, then it was our mistake, and in any event, we'd like you to exchange them now because we see that they're not correct.
Okay. As long as we put the cameras, as long as we record the cameras, I don't know why you care.
And Space Lab Marshal Ops, Ulf, if you have any more questions, we have about 2 minutes to go.
First of all, which set of...
Yeah, quick thing. We tried a little bit around in respect to your note, and we figured out there is no real difference as far as the accuracy of pointing is concerned compared to a 1G situation. If you do the famous ballistical pointing to your nose, to your ears, to your knees, with your fingertip, it works the same way as it works on the ground.
Okay, thank you, Ulf.
Space Lab, this is 102. The data sheets set A or B or C, sheets 1, 2, and 3 should be filled out.
Okay.
And Space Lab 102, pay particular note to the last sentence on sheet 3, which says, amplify report of results on the tape recorder as appropriate. Dr. Money would certainly be anxious to get a narrative of either the experimental results as reflecting the training or any unusual awareness of position reports you would like to have us know.
Space Lab, Marshall Ops, through TDRS for 54 minutes.
Roger, go ahead. Steer ballistically with your right hand.
Space Lab Marshall, we're ready to flow TV if it's okay with you guys.
We aren't to the 15-minute section yet, but we'll be there in about 10 minutes. The main Okay, Chuck, you can start flowing TV, and I guess we won't need to turn the recorder on. You'll want TVC2.
Stand by. That's affirmed, Bob. We'll take care of it. And we got video. And you can ignore the 21A pointing failure message. Space Lab Marshall, we're going to lose KU band coverage here in a minute. We're going to start the recorder for you. That's AV1. After that, you'll have to turn it on and off as appropriate.
Okay.
No, we've... Space Lab Marshall, we're just handed over to Mila, and we can flow video if it's okay with you guys. Space Lab Marshall, notice that it's about time for when we thought you'd be taking some pictures with the 33 camera. Just a reminder, you can go ahead and use Alpha 33 Alpha to check your magazine frames remaining. And for whichever one of you is free, we'd like to go through a few instructions on a TV setup we'd like you to make at this time to support the metric camera removal, which will be at 2224. And I'm ready to give you some instructions.
Neither one of us is free because we're doing this FO4.
Copy.
We can talk to you later. Okay, POCC Space Lab, are you still there?
Sure are. Read you
okay, you want to talk to us about the metric camera?
Yeah, we've got a Goldstone pass coming up a little ways downstream, about 22 hours and 24 minutes. And we've got the opportunity to look at real-time TV at that point. The guys up at Huntsville are awfully anxious to watch you do the camera removal. And we've got a setup using TVC1, which will let us look at that, and then the guys can see what the 33 camera removal looks like. We've also got a request from 19 Alpha. While we got you here, they're not seeing their cover closed and wondered if you have a free second or two, if you could peek out the window and tell them whether 19 Alpha cover is closed or not.
Okay, we'll go do that right now.
Okay, I'm on my way, Jose.
Okay.
By the way, POCC, we finished with excitement FO4.
Roger.
Guys still flowing TV?
Not at this point, Bob.
Okay, we'll turn them off. Okay, give me the TVC1 for Big Brother.
Okay, TVC1 should be mounted on Lima 3 X-ray with the field of view covering the metric camera area.
Okay, we'll do that for you.
And we'd like lights 1, 2, 3, and 6 turned off, OFF.
1, 2, 3, and 6.
Okay.
And I can tell you 19... Sorry, go ahead. Marshal Ops?
Go ahead.
Okay, 19 cover is closed, but 23, Dita Andresen's experiment is still open.
Copy that, thank you.
And I see also one ISO door still open.
Roger.
Okay, I'd like to ask one question, quick one.
Go.
Can you ask the 34 people whether the microwave experiment worked?
Stand by. Space Lab Marshal, while we're getting an answer on the 34, Ulf, can you tell us which door on the ISO experiment is open?
Yeah, 1 second, please. from the nose of the airplane. It is the second door. That means in plus X direction, it is the the fourth, which is open.
Second from the front.
Second from the front. That's good.
Copy that. Thank you.
I understand we're going to do this metric camera removal at 2224 in a Goldstone pass.
That's affirmative, Bob. And to this point of 34, we never got the high voltage really on the traveling wave tube, so it worked only in the radiometer mode. Over.
No comment.
Loud and clear.
Okay, any other things going on, TOCC?
Oh, yes, Bob. You are informed about the activities beyond hour 23, over.
No, what's up?
Experiment 025 for you and for Ulf, over.
More excitement.
And the Space Lab, we want Ulf 25 on live TV at 2300.
Is that for PA or is that for control?
We want to see the balls live on TV. I'm sorry. On 2300, over.
Okay.
And Space Lab, Marshall Ops for Ulf, this was a request from the PI, over.
Give my love to Helen. Hey, John, can you tell us where we are here?
And Space Lab, Marshall Ops, 2 minutes from LOS.
Okay, thank you. And we'll watch out for Holland, Bobo.
Thanks very much. You know, only one picture is good enough.
We have still about 40 pictures. We can cover it from south to north, provided the weather is good.
And just as a reminder, MAC remain is equal 70 as minimum, over.
Yeah, we took about 30 along the east coast of the United States, so that means there are 40 left.
Roger, and could you get also close to New York?
First pass, we had to talk to you all day with good comm, and there's nothing to talk about.
Bob, based on that last comment, we offer you the opportunity to offer a debrief on 102.
Didn't do 102.
Then, of hands, fingers,
over there to activate it. I think that's all that is. Yeah, I'll believe that. There are some call-outs for ICM switches, throwing switches in the EI time frame. Not sending anything from the ground. Now the VAS may wind up on if, well, no, even the VAS is going to be turned off. Well, supposedly they want TV. Not during TIG. Yeah. They won't get it. They arranged for a last up around do all that. TV of what? I can't believe any of this. Neither could I. Send me the piece of paper you have that makes you think this is all happening. Okay. Okay, we're there. Okay, let's get some modulation. Now let's get a forward link lock. It's sweeping, we'll lock. Let's have things locked up. Let's have things. Okay. And we're in blockage. So. Okay, TWT on. Going up.
Space Lab, this is Marshall Operations with you through TDRS. How do you copy?
Oh, loud and clear. Hi, Mike. Nice to hear you.
Good morning, Ulf. Good evening, Ulf. How's everything on board?
Everybody's fine. We had a little system problem right now. That's why we are running a little bit behind with the electroshock. Bob was busy to fix the subsystem computer.
Okay, thank you very much. And Ulf, when you or anyone there is ready to copy, we have some instructions concerning the Experiment 33 operations that'll be coming up on this pass.
Okay, I'm ready to copy. I'll just pull out my notebook. First question we'd like to raise is whether you want to see it on live TV.
That would be terrific if we could get some live TV coverage of this, or video recording is also a good possibility. The mission management people have asked to get some sort of video recording of the removal and stowage of the O33 camera, and are particularly interested in getting either a real-time downlink or a video recording of steps 17, 18, 19, and 20 on your detailed procedure, page 24. This is when you swing the camera loose from the overhead latches and remove it. They would also like a wide, tight, and then wide camera field of view to record that. This is particularly interesting to those who've been working on the rotating latches which secure the camera against the ceiling. Finally, we have been asked to comment that at 22 hours and 26 minutes, we believe we'll be passing over the eastern coast of the United States. If there are any frames left, you might want to use up the last few there. You are supposed to leave one or two on the reel, however, in order to facilitate its removal from the magazine. Do you know how many frames you have left?
We should have roughly 40. We got from Umo that we had 70, and we took already 30 when we passed over the East Coast during the last trap. So there should be 40 remaining.